Hello, and a big welcome to today's webinar, which is brought to you by Enscape in partnership with NVIDIA. Thanks for joining us, everyone. Great to have you here. Today, we are going to have a look at some of the latest trends in real-time visualization. We're going to dive much deeper into NVIDIA DLSS technology and hear about the impact of real-time rendering and visualization at the architectural firm Lake Flato. During the webinar, you will have the opportunity to get involved with the conversation by sharing your comments or asking a question. I'd really encourage you to do that. We are live, so please feel free to make good use of that questions box. All right, so today we will hear from 3 guest speakers who have each prepared a short presentation for you. First up is Andrew Rink, who heads up the marketing strategy for AEC at NVIDIA. Then we will have Clemens Musterle, who is the team lead of rendering development at Enscape, before we move on to our final speaker, Dan Stine, who is Director of Design Technology at Lake Flato. So thanks to all of our speakers for joining us today. Really excited about the content we have lined up. So now I'm going to hand control over to Andrew. So hi, Andrew, welcome, thank you for joining us. Let me make you the presenter now, and then you can share your screen and we can dive straight into the presentation. Get going.
Thank you, Gemma. Hello, everyone. Really great to be here with you today. Thanks so much for joining us. Hopefully, quite a few of you know that NVIDIA has been developing visual computing technology for the AEC industry for many years now. Some of you may know that back in 1999, our company invented the GPU. And at that time, our products were focused on graphics acceleration, essentially helping architects, designers, engineers to work faster and more smoothly with their advanced design and visualization tools. So 99 invented the GPU. Then we introduced the CUDA programming model in 2006, which opened the door to using the parallel processing capabilities of the GPU for general purpose computing. So of course that enabled high performance compute applications, like for instance, accurately simulating wind flows around a building, just to offer one example. And all kinds of HPC workloads could be performed much more quickly than with using CPUs. And NVIDIA has been pushing the boundaries of visual computing ever since. And ultimately, these past few years, NVIDIA's compute platforms have become the power behind many of the pretty astonishing artificial intelligence enabled developments that are beginning to bring benefits to all industries, including AEC. We've all heard about autonomous vehicles, probably mostly in the context of self-driving passenger cars or robo-taxis. But that's technology that will appear on construction sites in the not too distant future. We'll be seeing self-driving bulldozers, excavators, dump trucks, all types of autonomous construction vehicles being deployed to work faster and to make sites safer. And NVIDIA provides the enabling technology at the center of that development. It's the same with autonomous robots and drones, which can be trained with deep learning algorithms using NVIDIA SDKs and GPUs, and in many cases powered by our Jetson TX boards. These are increasingly being used for monitoring construction site progress and for accelerating all kinds of reality capture processes. Another area relying on NVIDIA technology is deep learning enabled video monitoring for safety compliance on construction sites. This is technology that alerts supervisors in real time about risky on-site scenarios, such as workers not wearing PPE, personal protective equipment like safety vests or hard hats. And also AI is being used to improve and automate infrastructure inspection. There are some wonderful tools available now to more effectively and efficiently record, for example, cracks in tunnels and bridges. And this helps, of course, remove the subjective human assessment of these defects and to reduce the monotonous nature of such critical work. And AI has even been integrated into design and visualization software. There are numerous CAD software companies making significant progress with using deep learning to develop applications like generative design, which also rely on NVIDIA technology for training and reference. inference. These tools have the potential to dramatically reduce the amount of repetitive tasks that human designers have to tackle. And as you may have heard about AI-enabled rendering denoising, especially if you're an Enscape user. This ability to accelerate photoreal visualization of digital models is something that NVIDIA developed. And today you'll hear more from Enscape about the latest AI-powered technology from NVIDIA for improving real-time rendering, what we call DLSS, or deep learning super sampling.
You can ask the audience. We just wanted to ask everyone a quick question. Are you using real-time rendering in your design workflow? And there's a few answers that you can choose from now. So yes, not yet, but you're planning to adopt within 6 months, or no plans at this time. So if you could select the appropriate option, and then we'll have a look at the results and see who we've got in the audience today. Give it a couple more seconds. Looks like most people have voted, so let's have a look at those results. Wow, 78% are using real-time rendering at the moment in their design workflow. Amazing. Just 15% not yet, and 7% no plans at this time. All right, so now I'll hand back over to Andrew. If we can share the slides again, Andrew, and let's just check it's on the right one.
Well, so thanks for that, Paul. That's really interesting to see those results. And before we get to the main part of the presentation from Clemens and Dan, I thought it might be of interest to highlight some of the key GPU accelerated workflows that we're seeing in the AEC industry. So of course, 3D models and BIM data sets continue to get bigger and more complex. Added to that, with the introduction of real-time ray trace rendering with NVIDIA RTX technology, architects and design teams are finding that more accurate renders of those massive, non-decimated models are helping drive better and faster decision making. So no doubt you're seeing the complexity and the quality of renders is increasing. Fortunately, we're keeping pace with more powerful GPUs with larger memory, so you can handle those kind of workloads. Another big visual computing trend in AEC is using immersive virtual reality throughout the building design phase and beyond. VR has established itself as a really important element of design and design reviews, and there are use cases that go beyond the design phase into construction, with many companies finding a lot of value from virtual construction rehearsals. Practicing that work in advance in VR helps teams identify problems ahead of time and improve safety by identifying potential risks. And VR is helping sell properties too, right? Long before they're built. Then there's the never-ending challenge of collaboration, which in many ways is further complicated by team members being geographically separated and working remotely. NVIDIA faced those same challenges ourselves. So we developed an internal platform for virtual collaboration and simulation, which we called Omniverse, and it's now available as open beta software to everyone. And this platform allows teams to use their preferred design tools like Autodesk Revit, ArchiCAD, Rhino, or SketchUp, for example, to connect to Omniverse and work with their entire team simultaneously on a single model that updates in real time. And they can visualize that model in the highest fidelity using RTX technology, and of course bring that high quality experience to their clients too. So it's been several months that we've launched the open beta, and so far hundreds of firms have evaluated Omniverse, and we have over 50,000 registered users of the open beta. So Omniverse is going to be a game-changing platform. We're very excited by Omniverse, and I encourage you to check it out. Just search for NVIDIA Omniverse online, and you'll find a ton of info to learn more. This last trend that you see here, well, it's the adoption of practical AI-enabled tools that are being used today, and I pretty much covered this a little earlier. Really, the key points I wanted to make. It's certainly an exciting area of development, but really, without further ado, let's hear all about DLSS from Clemens at Enscape, and then Dan from Lake Flato. So I'm really pleased to hand over to Clemens there.
Thanks a lot for the introduction. Let's see if that works in my case. Can you see the right screen now?
Yes. Looking good.
And it's the main screen, not the presenter screen.
That's right, full slide. Well done.
Okay, perfect. So yeah, thanks again for the introduction. My name is Clemens Musterle, and as Gemma introduced me, I'm a team lead for rendering development here at Enscape. And today I'm going to talk about the integration of NVIDIA DLSS into Enscape, which we've released with Enscape 3.1. So let's have a look at the talking points of this presentation. I'll first cover the basics. What is DLSS? What's the motivation of adding DLSS to Enscape in the first place? But we also want to understand what is DLSS on a technical level? Why is it superior to previously used techniques in Enscape? And then we'll have a look at those benefits in Enscape regarding image quality, performance improvements, and how DLSS enables other quality improvements on top of that. So in real-time rendering, we face two trends today. On the one hand, everybody's heard about real-time ray tracing. It allows us to compute such effects as path trace, global illumination or reflections, or ray traced sun shadows, for example. But those calculations come still at a relatively high cost, despite the hardware acceleration that we have, for example, with RTX hardware today. On the other hand, there's a trend towards ever higher resolution displays in monitors and VR headsets to provide those super crisp immersive displays. But that means we have literally millions of pixels to calculate with ray traced lighting, and all of that in only a fraction of a second. So that's a huge challenge. However, if we can reduce the amount of pixels we have to do those expensive shading calculations for to only a fraction of our monitor's display resolution, and at the same time we can still output a high resolution, high quality and sharp image, this will mean that we can get a significant speed up proportional to that reduction in resolution. And that in return allows us then to reinvest some of those performance savings to achieve even better rendering quality and still reach higher frame rates. We'll come back to that statement later when we look at the results in Enscape. So yeah, as Andrew already mentioned, DLSS stands for Deep Learning Super Sampling. Let's have a brief look at the technical background. It's a so-called temporal image upsampling technique, and that means it takes information from a sequence of lower resolution frames and is able to generate a high resolution image out of that. To see what that means and why DLSS is superior to previous techniques, we go back one step first and have a look at a predecessor technique called temporal anti-aliasing. So in computer graphics, when we render an image at a given resolution and consider a pixel only as a single point, we immediately get a very unpleasant effect called aliasing. It becomes visible as what we see as jagged edges. So in this example, the triangle shape we are trying to display actually gets almost completely lost with the low resolution of only 6 by 6 pixels. So we can hardly identify it as a triangle anymore. And we've all seen that in low resolution images. We've looked at a computer screen that don't look really nice. So as a pixel actually covers an area in a 2D example like here, a single sample does often not give a good representation of its content, because what we want to have is a color that's proportional to the coverage of the pixel. So for example, here on the border of the triangle, that's always a mix of the triangle's color and the background color, depending on how much of each is visible in each pixel. We can solve that if we simply calculate more samples per pixel and then average the colors of the individual samples as seen here. This is a technique called super sampling. This way we can get smoothed edges and with that a much better representation of the original shape. However, calculating those additional samples is of course not free. In fact, it would multiply our performance cost by the amount of samples we take. So with only 4 samples, we usually don't even get a very smooth result. We need more samples than 4. And that does, of course, not scale very well for real-time rendering, where all of this has to happen in a fraction of a second. So what is often used in real-time rendering is a technique called temporal anti-aliasing, which is also what we use at Enscape. It solves the issue of the cost of multiple samples by distributing them over time, meaning we calculate only one of our subpixel samples every frame. What it means is we basically jitter our camera by a super small offset in every frame, so our individual frames look a little like this jittered animation on the right, and you can see the schematics on the slide how the subpixel positions inside the pixel move over time. To calculate the averaged pixel color, we reuse the previous frame's information. And that way we can accumulate an anti-aliased result over time. You can see that in the animation in this slide. So while we start with the very jagged edges at this roof, over time it converges to an anti-aliased image. However, once movement comes into the equation, things fall apart. We get an effect called ghosting, and that's because multiple images are now superimposed that don't belong together like that. So to solve that, an algorithm needs to decide if information from previous frames can still be reused or is still valid or not. You can see that here on the example on the right. If you look at the current frame and we focus on this area of the window here, and if you see what has been on the same position in the previous frame, we can identify, all right, this was actually covered by the trunk of the tree, so we can actually not reuse that information. And to decide if we can reuse the previous frame's information is a very difficult problem to solve with a conventional algorithm, and it needs a lot of tweaking to make that work in all kinds of different scenarios. Temporal image upsampling uses the same principle as temporal anti-aliasing. However, the subpixel samples of our rendering resolution may now contribute to multiple pixels of our output resolution, as it's shown here on the right. More samples are needed, but over time you can reconstruct the high resolution image without a loss of quality. However, when movement comes into the equation, things get even more problematic than before, because we have even less reliable information to work with, and so we need to make more difficult decisions in our algorithm. We either have to be very tolerant in accepting samples, which then leads to the before seen ghosting or a general blurriness in the image, or we accept only samples with a very high confidence. However, that can lead to flickering over time, an unstable image, which we also want to avoid. Now, DLSS replaces the conventional temporal anti-aliasing algorithm with a deep neural network. So the neural network has been trained with a huge amount of image data, and it can better reconstruct a high-resolution image based on the individual frame samples and other data. We'll have a look at what it is later. The results then are in this results then in a much better, higher quality upsampled results. So it solves the issue of ghosting, and the image sharpness is often on the same level or even above the native resolution conventional temporal anti-aliasing. So this is basically how DLSS works. We input the low resolution jittered frames, as we've seen in the animation a few slides before, and additional information about what the scene looks like depth or motion vectors, which describe how the pixels move between the certain frames. And then the hardware accelerated neural network is executed on your RTX graphics card, which has dedicated hardware for that, the so-called tensor cores. And what we receive is a high-resolution anti-aliased result. Now let's have a look at what that looks like in Enscape. So this is a small example of an animation rendered in Enscape, small video, nothing spectacular about it, and I hope it translates well into the stream. Now we want to have a look at a single frames of this video and compare it to different implementations. So first have a look at the native resolution. So overall, the image quality is quite good. We have sharp result. We have good anti-aliasing. So the edges, for example, of the building are anti-aliased quite well. However, this is a particularly difficult scene for conventional temporal anti-aliasing because we have a rather fast camera movement to the right, if you remember. And if you look at the background, there's lots of trees and they overlap and they all have kind of a similar color. And that makes it difficult for the conventional algorithm to decide which information we can reuse or not. And unfortunately, we can see the before seen effect of ghosting if we zoom into the image. And if we then, so this is a native resolution image, and if we then use a regular temporal anti-aliasing upsampling, as has been used in the past, the overall impression is also quite okay. The shape of the geometry is reconstructed rather well. Also, the anti-aliasing is okay. However, if we zoom again into this problematic area, we can see that the effect of ghosting is a lot worse. And we also have a noticeable loss in sharpness. Now, and that's an upscale factor of 1.5. And now let's compare the same upscale factor with DLSS. And as you can see, rather obviously, the effect is much better. We have a lot crisper image. The ghosting is gone completely. And we can, if you compare it to the native resolution rendering before, we have even increased sharpness. So far for the image quality improvements with DLSS, but as mentioned before, the main benefit is of course performance. So as a user, you don't have to worry about that before mentioned upscale ratio. All of that is done automatically with what we call the DLSS auto setting, which determines the upscale ratio based on your monitor's resolution. So for example, if you have a 1080p, or full HD monitor, will upscale in the so-called quality preset from 720p, which is 1.5x. And if you have a 4K resolution monitor, will upscale from a 1080p resolution. DLSS is enabled by default if your GPU supports it, that an NVIDIA RTX GPU is required. And for video capturings, we always select the quality preset just to ensure the best possible quality in the outcome. Let's have a look at the performance numbers. So at a 1080p resolution without DLSS and in the scene which we've seen before, we get an average frame rate of 46 frames per second, which is quite smooth. But if we compare that with DLSS on, we are above 80 frames per second, which is above the importance threshold of 60 FPS. So it's a very smooth experience. On a 4K monitor, we get an even higher increase in frame rate. So we start with a 13 FPS without DLSS, which is of course rather choppy experience. With DLSS on, we almost triple that frame rate to 38 frames per second. So we are above the 30 frames per second threshold, which we are used to from videos, for example. Another example is DLSS used in VR. So if you look at the chart here, this is a performance measurement done with the HTC Vive Pro 2, which is one of the most high-resolution displays available for VR today. And we run it on an NVIDIA RTX A6000, so also one of the most powerful GPUs today. And with DLSS off, we manage 60 FPS, which is solid. But for VR, you usually want to have above 90 FPS to get a completely smooth experience and to avoid things like motion sickness. And DLSS allows us to do that easily. We reach 100 FPS with DLSS enabled on that HTC Vive Pro. So these performance gains we achieve with DLSS, they give us headroom to further increase rendering quality. One of the things we've added after we've introduced DLSS was adding the NVIDIA real-time denoiser for the Enscape 3.1 release. The real-time denoiser helps in reducing the amount of noise we can see, especially in closed indoor scenes like that. We often struggle to get rid of all the noise. So if you look into this zoomed in regions, you can see the overall image looks great, but if you focus on the details, there's still some noise we couldn't get rid of. And the NVIDIA real-time denoiser eliminates that noise completely, and we have fantastic, smooth results. But of course, this comes at a certain cost. The same applies to ray traced sun shadow, another feature we've introduced with Enscape 3.1. However, back then it was only available for still images. Now with the upcoming Enscape 3.2, we make ray traced sun shadows available for real-time walkthrough. So it has to be a lot more performant, and what you get out of it is much improved accuracy of shadows during walkthrough, but also in videos. And what that looks like is shown on the slide here. So this is conventional shadow mapping, so without ray tracing. At a first glance, everything looks okay, but if you pay attention, you can see that some of the shadow of the chair is really blurry. Some of the detail is lost in those shadows. And if we switch over to the ray traced version, this becomes even more obvious, because now we can see all the delicate detail of the geometry is visible, and we have physically correct smooth shadows. And you can also see, like in the plant in the background, previously the shadow was basically lost. And with real-time ray traced shadows, we can recover all that detail to give you the highest possible fidelity. But of course, these quality improvements come at a certain cost. However, when we look at those performance charts, we can see that DLSS not only mitigates those costs, we have an even higher frame rate than without those features before. So if you look at the performance of the NVIDIA real-time denoiser, we were reaching, without the real-time denoiser and without DLSS, we were reaching around 80 FPS before. Now with the denoiser enabled, we are at 100 FPS as long as we run with DLSS. So we had the better frame rate, even though we can achieve a higher quality image. And the same goes for the ray traced shadows as well. So with the ray traced shadows off and without DLSS, we are above around 50 FPS in that case. And if you were using the ray traced shadows without DLSS, we would be far from 60 FPS. But with DLSS and the ray traced shadows, we are still well above 60 FPS. So to sum that up, DLSS increases real-time rendering performance significantly, and that of course allows for a smooth walkthrough experience, especially on high-resolution monitors and VR headsets. But at the same time, the image quality is reaching or even surpassing that of native resolution rendering. And at the same time, DLSS allows us to push the rendering quality even further without sacrificing performance so much. So we can add even more expensive ray traced lighting calculations that were not possible to do so in real-time rendering before. And with that, so far my presentation. I'll hand over to Dan Stine next.
Thank you, Clemens. Dan, I'm just making you the presenter now, so you can get ready on your side. Excellent. All looks good.
All right. So you can see my screen all right?
Yeah, looks great.
Awesome. Thank you. And thanks for having me. So we're NVIDIA is making the hardware, the GPUs, and Enscape is creating the real-time rendering software. I'm coming to you as a customer in the AEC market, and I suppose for a little street cred about who I am and who Lake Flato is, in case you haven't heard of us, I'll give a quick intro. So I am a registered architect in the state of Wisconsin. I teach graduate architecture students at NDSU, going on 7 years now. I've written 14 textbooks in this space of AEC and design technology. One of those books being the #1 Revit book in North America. I also write blog posts for my own blog, BIM Chapters, but also for Enscape. So I wrote the post on announcing DLSS on the Enscape website. I've presented internationally, and I'm the chair of the IES National BIM Standards Committee. And also, most recently, something I'm really excited about is I was co-author of the AIA Climate Action Guide for Practice. Lake Flato, Bureau Happold, and then 2 other individuals worked on this project. It's forthcoming. It's actually not out yet. And Lake Flato, if you haven't heard of the firm, is based in San Antonio, Texas, with an office in Austin. I'll let you read most of those yourselves. I'll just point out in 2019, Architect Magazine ranked us the #1 firm in the US in their top 50 list. We have won the most AIA Coat Awards than any other firm in the US. And the firm has 6 books published on projects that we've worked on, with another book forthcoming. In terms of Enscape use at Lake Flato, we have 80% of our design staff that actually uses Enscape, and that's essentially almost 100% of those who are doing design visualization tasks. It's our only visualization tool that we use in the firm, short of hand sketching and Photoshop. We use Enscape in conjunction with Revit, SketchUp, and Rhino. And we use Enscape pretty much daily for design, client presentations, extensive VR. The little graph on the lower right shows our usage for the last 180 days, and all the dips are weekends, so it doesn't go down to 0, but goes down quite a bit on the weekends, thankfully. And just real quick, I was actually at NVIDIA GTC in 2018 as a presenter as we lead into the discussion about DLSS, and saw NVIDIA's CEO announce RTX technology, and have been using Enscape myself and working closely with many of the folks at Enscape since 2015. Here's a quote from one of our partners in the firm. I'll let you read that. So the firm finds a lot of value in the use of Enscape, and we also see that it benefits our clients greatly. The benefits of NVIDIA DLSS to an architecture firm like ourselves is we work on a lot of, over half of our projects are national, and so we have these really large, complex projects that we use Enscape to deliver presentations, informing the client about the project. And these can either be remotely over Zoom meetings or in person. So to have the ability to open up a large data set and not have to hide things and turn things off, and since one of our main goals in a project, in addition to sustainability, is to be sensitive to the site of the project. So adding lots of trees and vegetation, which are really resource intensive, especially with Enscape's ability to have these things blow in the wind as you move around. We have standardized on the RTX Quadro 5000 graphics card, and that's largely because of its large frame buffer. The 16 gigabytes of GPU memory allows really large projects with lots of textures to be loaded and work well for both on-screen real-time rendering and in VR. So the value, as Clemens mentioned, and some of his statistics were using the same graphics card, in fact, are that we can now do more with less, we being the customer. So using Enscape and RTX graphics cards, our bigger projects that we opened up just before this version came out would have ran a little slower and not quite as smooth. So we're seeing improved quality there for sure. And then this, again, benefits our clients where we can show really crisp, accurate representations of our projects without the distraction of ghosting and jagged edges. Here's an example. We're currently using Enscape as part of the design process for remodeling our own office here in San Antonio that's approximately a block and a half away from the Alamo downtown. In the top frame with RTX turned off, as you're just moving through the space, not necessarily doing anything extraordinary, as Clemens showed with the tree, you can see ghosting of things that are in the foreground relative to objects further away in the background. And so any sort of movement through the space, you tend to see this. And while many people don't think about it or bring it up necessarily when we're looking at it ourselves or meeting with clients, it can affect the perception of colors and materials and be a subtle distraction. So you compare that with the image below with RTX on, and the quality, the ghosting is gone. You can see the some of the objects in the background are more crisp and just an overall better experience. As timing would have it, something that certainly relates to NVIDIA, Enscape, and DLSS is a blog post that NVIDIA published on Tuesday of this week, highlighting a proof of concept that Lake Flato worked on with White Hat Virtual Computers, a VDI-focused company based in Austin, Texas. So we had the opportunity to test two NVIDIA A40s in a Dell host. So the A40s have 48 gigabytes of GPU memory, and we divided that up into 8 power users with a 12 gigabyte frame buffer. And we were using this to drive Revit, Rhino, SketchUp, and really the benchmark for everything was Enscape, as that's one of our most resource intensive applications that we use. And another thing that was really amazing about this is that we were able to get what currently is a desktop computer with an RTX 5000, pretty similar performance, and down to 94 watts per person. That's for the that includes the GPU and the CPU. The computer is running at 94 watts in running Revit and Enscape at the same time. And then finally, the VR aspect. We tend to do a lot of VR, whether it's in the office or at the client site. Here you can see an intern from UTSA School of Architecture that worked with us over the summer, actually making some really awesome high quality textures. We revamped our entire library basically benefiting our Enscape presentations, having really good textures with bump maps and height maps and things like that. But the great thing, again, as Clemens mentioned, is that the upscaling frees up resources to do more with less, so higher frame rate. So our clients in particular aren't getting motion sick, and they're much happier to spend a lot of time in VR. We recently had a client in the office, and and they spent close to 4 hours in VR trading between the design architect and the client, but that was also running Revit with Enscape running live against Revit, and then toggling into VR so that the client was in VR and changes were being made in Revit while the client was in VR. So having DLSS enabled and a really powerful computer with a good NVIDIA graphics card, you have to have an RTX NVIDIA graphics card to take advantage of this DLSS. If you don't, you don't get the benefit, and Enscape's able to discern if it's a pre-RTX or another manufacturer and just not do anything. But when you do have it, it's automatically toggled on, and it has made a pretty significant improvement in quality. And as Clemens mentioned, the HTC Vive Pro 2, for example, which is 5K and 120-degree field of view, and what you can see on the screen here, the Quest 2 actually running wireless against a wireless access point, a dedicated one, just plugged directly into the computer. At I think the Quest 2 is 3.5K or 4K. And then finally, just a closing thing that's also related, some testing that I've done recently on NVIDIA Cloud XR, which is the opportunity to, in the case of my testing, open up an Amazon AWS instance that's in a data center on the West Coast, fire up an Enscape standalone EXE, and then here in San Antonio, Texas, in the same Quest 2 headset, connect to that remote computer with the Cloud XR functionality, and have a reasonably good, not perfect, but considering where we're at today, to be able to run VR from across the country, a full Enscape VR experience is pretty amazing. So that's my quick intro on what an architecture firm is doing with this technology and how we see it benefiting ourselves.
Brilliant. Thank you so much, Dan. If I can invite the other presenters back on, and we will take a few questions now. Let me just put my screen in the right mode. There we go.
Dan, it's great to see really the leading edge work that Lake Flato is doing. You're really pushing the boundaries of technology. It's excellent. You know that it's so helpful for companies such as NVIDIA to see you know, innovators such as yourself in the industry really forcing us to continue to innovate and improve our products.
Yeah, thanks. I have a really fun job.
You do. Yeah, Cloud XR really is another one of those breakthroughs. It's interesting because Dan, you know, at the beginning you mentioned, you know, Enscape does the software, NVIDIA does the hardware. In fact, as I kind of pointed out at the beginning of my intro to NVIDIA, you know, we're a platform company really, but the more than half of our employees are software engineers, so we're really a software company today. You know, Cloud XR is an SDK, so it's a perfect example of the kind of software that we deliver. Of course,
yeah,
DLS.
I was keen to that point myself, but it made more sense in the big picture of what
Absolutely.
I was talking
about. Yeah, for sure. Yeah.
Great. We have had a few questions come in, so we could tackle those before we wrap things up. So let's start off with Dan. Someone here is just asking about your VR headsets that you're using at Lake Flato, and one person was wondering if you're utilizing Oculus Air Link or the Quest 2 to run Enscape.
Excuse me. Yeah. So the Quest 2 has been quite the go-to tool recently because of its ability. So we'll render stereo panoramas out of Enscape, for example, and load those into Ulio. So that works on the Quest 2 where everything just lives on the device. But then we'll also use the Link cable or the Air Link, as was mentioned, to do the wireless hotspot, which work, that's a recently new development with the Quest 2. And I actually pulled a old hotspot out of my closet here at home and plugged it in, and it worked great for wireless VR in a full Enscape VR experience.
Fantastic, thank you so much. Clemens, there's one here for you about DLSS. When you open Enscape, is DLSS automatically turned on, or do you need to manually?
Yes.
Yeah.
Provided you have the right hardware, so you require an NVIDIA RTX graphics card. So independent from the series, as long as it's got the name RTX in it, it will be enabled by default. We determine that during startup what kind of hardware features are available on your GPU, and by default this will then be enabled. You can check that also in your general settings, and on the renderer settings there's one box, hardware settings, and there you should see the NVIDIA DLSS checkbox enabled, just to make sure that it's actually on.
And another related point that I just thought of, again, with the ability for Enscape to do more with less, that also means that it works great on lower quality graphics cards. So far we've only mentioned like really high-end graphics cards, but at home here I have a Dell 5750 that has a RTX 3000 in it, and so that again allows you to do more with less, which is the point.
It's probably worth me pointing out at that point, since you're going down that path, Dan, to in case everybody hadn't heard yet, we recently announced a 2000 series RTX GPU, the RTX A2000 desktop. So that's bringing the capabilities of RT cores, tensor cores, all of that, all those new cores in addition to the CUDA cores into a lower level, a sort of entry mid-range GPU, very affordable.
Fantastic. I'm just trying to read and listen at the same time. It's not always easy, but we have another question here. I think, Dan, this may be for you. Just want to confirm Dan's statement. Is DLSS for Enscape limited to running in the native program, or can it be utilized with exported Enscape files on a device with an RTX GPU?
That's a question I asked Clemens during when I was beta testing it, and maybe well, I guess I know the answer now, but yes, it is embodied in the standalone EXE, and then that standalone EXE has the ability to discern what computer it's on to whether it can use DLSS and the RTX functionality. Is that correct, Clemens?
That's correct, yeah. So I'm not sure if you're only talking about EXE standalones or also video exports. So for video exports, it's also used if it's enabled. So you get the speed up as mentioned before. We're doing that with the highest quality. So the speed up you get in video rendering is still noticeable, but you cannot expect something like a 4x speed up for video rendering because that it just doesn't scale that well in that use case. It's made for real-time rendering mostly.
Yeah, and with the interesting thing then about the standalone EXE is that gets moved sometimes to a different computer, and that EXE has the ability to tell that it's on a different computer when it's opening, and would use or not use RTX depending on if it's available.
Great. A question here. Could either Dan or Andrew speak to the virtual workstation, the A40, and how it applies to architecture and design? Not sure if that's possible.
Yeah, maybe I can start off at a sort of general high level, and perhaps Dan can share a little bit more about the experience that the company's had. So this is technology, so of course virtualization technology has been around for quite a long time. One of the challenges that the technology faced was that it wasn't a very smooth experience for the advanced design and visualization software tools that many of you on this webinar are using. So it was really mostly for sort of kind of non-graphics intensive workloads, maybe an Excel spreadsheet or something like that, or Word, using word processing tools. So it was great for that. But there was a challenge. So what happened in 2014 was NVIDIA came up with a new technology, which was called a grid back then. and it's now evolved into vGPU, so virtual GPU technology, where we introduced the ability to accelerate virtual machines through our RTX VWS software now to enable users of virtual machines to have pretty much the same graphics experience with tools such as Enscape on a virtual machine as they get on a physical, laptop or desktop workstation. So that's the bringing VDI to the complex software workloads. And we have a number of different data center GPUs, such as the A40, which users can connect our RTX VWS software to those GPUs, and that's the proof of concepts that Dan was explaining. And there are different profiles to enable us to, to enable the users to share the GPU resources from the data center. That's the high-level kind of a description.
Yeah, I could add a little bit to that. Backing up slightly, our current topology is that everybody in the firm has this Dell tablet, which is basically like a Microsoft Surface. And we remote in using VMware to a Dell Precision desktop with an RTX 5000, and it's using the VMware Blast to allow us to use tools like Enscape and other simulation tools that use the graphics card. And so then our recent testing, as we're remodeling our office and looking at power consumption and again, Enscape being the benchmark, the two A40s and a Dell host have proven to be extremely capable, where we're running the GPU profiler as we're doing pretty unusual tasks, trying to just push it to its max, like running the Revit RFO benchmark on like 5 or 6 of these computers and opening up the really high quality Enscape exe that you can download for free from their website. And then also opening up some really large projects that we have in-house and all along on the consultant that we're using that I mentioned, there's so many variables in VDI, like GPU scheduling, and there's hundreds, if not thousands, of little switches. And so that white hat virtual computers are, some of the most talented people I've worked with in this space. They really know what they're doing. And we came to a really optimized solution that's scalable and again, for 94 watts per person is the entire computer, not including the monitor.
From an industry trends perspective, I'd mention that I think we all probably recognize that it's widely recognized in general that the AEC industry is not an industry that typically is an early adopter of new technologies. But I would say over the past, let's say 5-6 years, there's 2 technologies that I've seen the AEC industry really embraced because they're seeing an ROI. This virtual GPU, or the graphics accelerated VDI, is one of those areas. A lot of firms, obviously in the situation we've been in for the past 18 months, have realized the ability to allow employees working from home to have equivalent experience on a lightweight laptop that they might be using a PC or something, able to harness all of that GPU technology from the data center through RTX VWS software. They've got a wonderful workflow experience from wherever they are. So this has been one of the technologies that's really been picked up by the architecture firms particularly. And the other one is VR. We've been speaking about that. There's been a lot of progress with, of course, the GPUs, right? That enabled a lot of this, those fast refresh rates that you need on the HMDs to have a good experience. And of course, the HMDs have been improving, becoming higher fidelity, becoming more affordable. And now with Cloud XR, we've basically got rid of the tether. That now all these all-in-ones will be are enabled by Cloud XR, so you have a really good experience, VR experience, immersive VR experience. So it's really great to see two, kind of complex technologies, really, certainly VDI is, and virtual reality being adopted for all kinds of use cases in this industry.
Brilliant. Thank you so much for that. That was really insightful. I think we may have to wrap things up as we're pretty much at the top of the hour. We've got through most of the questions. So thank you everyone for contributing those and asking those. I'd like to thank our speakers today, Andrew, Dan and Clemens. Thank you so much for sharing your insights with us all today. And to everyone else, there will be an exit survey that will pop up on your screen as you leave the webinar. I really encourage you to leave your feedback. We'd love to know how we can improve things for next time. So feel free to fill that in. We'd really appreciate it. And an email with a copy of the recording and quite a few useful links actually will be sent to you shortly as well. So keep an eye out for that. And with that, we'll wrap things up. Thanks once again, everybody. Enjoy the rest of your days, and we hope to see you on another webinar soon. Thank you so much, everybody.
Thank you.
Thanks. Bye-bye.